In this chapter, we will focus on enhanced versions of ER diagrams from Chapter 3. Enhanced, or sometimes called extended entity relationship diagrams, add semantical data to our entity relationship diagram. Here are the following topics we will cover this week. As mentioned, EER stands for Enhanced or Extended Entity Relationship. Our model concepts, such as how we model, in addition to our entity relationship, our extension. Our constraints of specialization and generalization, and our knowledge representation and ontology concepts. As we discussed in Chapter 3, the examples provided only featured certain attributes. We can build subclasses off of our attributes too. These subclasses are often written out as an is-and relationship. For example, a secretary is an employee. Think of the superclass as the entity and subclasses as the attributes. As previously discussed, the relationship can be defined using English verbiage. Note the importance of entities not needing to be associated with all attributes. Notice here, based on the union notation, these things here, we're limiting job type to only 3 options of secretary, technician, or engineer. Think of how Java or other programming language inheritance works. Specializations help further define how relationships are supposed to be interpreted. Extended entity relationship diagrams require we be more specific than general entity relationship diagrams, focusing on everything our database might need. This diagram suggests our employee can have 6 identifications. Can you name them? They're secretary, technician, engineer, manager, salary employee, and hourly employee. We could similarly have a superclass person with specializations which are generalized. Notice generalization by entity and generalization by superclass using the union symbol. Arrows may need to change based on your needs, so leaving them out helps us avoid any assumptions. Again, think back to programming languages with their classes and methods. Again, we are looking to be as detailed as possible to create a quality database, which is often why we do our diagrams ahead of time. For example, our employee entity will feature conditions of employee types. Our types of employee can serve as a condition or be chosen. Notice the single quote secretary, close single quote, provides a specialization definition, as does engineer and technician. Secretary, engineer, technician, specialization defined. Disjoint and completeness constraints further define how our relationships work. Figure 4.4 on page 114 and figure 4.5 on page 115 show how disjointed constraints and overlapping constraints are visually represented. All information from subclasses must be complete for the superclass. Each specialization determines the totality of the condition based on its applications. This disjointed diagram is total or partial. Can you determine which? It is total, as all of our subclasses have a specialization defined. Try to determine if our overlapping diagram is total or partial. Can you figure it out? Again, refer back to concepts detailed within a data structures programming course related to hierarchy. Notice all the unions. Here. Notice an engineer can also be a manager. Our engineer and manager combine for engineering manager. Again, there are similar constructs to programming. A database can feature both specialization and generalization, and often does, to meet all the needs associated with its input. Notice how employee and student can be defined in a variety of ways. Staff, faculty, student assistant, graduate student, undergraduate student. As previously mentioned, a union combines things. Just like a house, which can have an owner-renter or be owned by a bank. The diagram is showing us how an owner owns a registered vehicle. Owner owns registered vehicle. Many options here. Being as detailed as possible is our end goal in developing our database. Refer back to discrete mathematics of how subsets work. We continue to go into more and more detail in order to produce the best diagram, which helps us produce the best database. Union type T can be defined as Boolean, true or false. Again, UML diagrams are used by those with more comfort in them as opposed to an entity relationship or extended entity relationship diagrams. You'll notice again, UML notation is similar to our ER diagrams, but not exactly the same. UML diagram notations are represented here. Ontology is a specialization of the concepts and relationships within a database. Knowledge representation tries to present everything. Think of somebody who is an overthinker. They think about every possible outcome. We need to have as much is defined as possible. Classification creates smaller and smaller attributes. Think back to your biology courses. Instantiation is the reverse of classification. Similarly, the remainder of these concepts are discussed in great detail in your course textbook on pages 130 and 131. These ontologies allow us to give consideration to many possible attributes and their relationships. Hopefully, you now have a stronger grasp on diagramming an extended entity relationship diagram to best plan for creating our database.